Unraveling the mysteries of scikit-learn exceptions. Scikit-learn, a powerful machine learning library in Python, throws various exceptions to signal errors and issues during the execution of your code. Understanding these exceptions is crucial for debugging your models and ensuring their robustness. Let's delve into the details of common scikit-learn exceptions, their causes, and how to handle them effectively. 1. Common exceptions. Value error. Description indicates an incorrect input value or argument. Causes. Providing data with incorrect dimensions or shape. Feeding invalid data types, e.g., string instead of numeric to the model. Attempting operations on incompatible data, e.g., fitting a model with inconsistent feature sizes. Passing inappropriate hyperparameters to a model. Example: Python. From sklearn, linear model import linear regression. Model linear regression. Model fitx. Yx is a 2D array. Y is a 1D array. This code will throw a value error if x and y have incompatible dimensions. Resolution: ensure your data meets the expected format and dimensions. Review your code for incorrect data types or incompatible shapes. Type error. Description indicates an operation on an object of the wrong data type. Causes. Attempting to perform an operation on an object that is not designed for it, e.g., calling fit on an object that is not a model. Providing incorrect data types as arguments, e.g., passing a list instead of an array. Example: Python. From sklearn, model selection import train test split. Xtrain, xtest, ytrain, ytest train test split x. Y. Test size 0.2. Model fit xtrain. Ytest is supposed to be ytrain. This code will throw a type error because ytest is not the expected input for the fit method. Resolution: check your code for data type mismatches and ensure you are using the correct objects and methods. Attribute error. Description indicates trying to access an attribute that doesn't exist on an object. Causes. Incorrectly referencing attributes of an object. Attempting to access attributes before they are created, e.g., accessing model weights before fitting the model. Example: Python. Model linear regression. Model core. The model hasn't been fitted yet, so core doesn't exist. This code will throw an attribute error because model core is not available before fitting the model. Resolution: verify that the attribute you are attempting to access exists and has been properly initialized. Index error. Description indicates an attempt to access an element outside the range of a sequence. Causes. Using an index that goes beyond the length of an array or list. Accessing elements of a data structure using incorrect indices. Example: Python. x1, 2, 3, 4. Print x20 out of bounds access. This code will throw an index error because the array only has two rows, indices 0 and 1. Resolution: double-check the indices you are using to access elements in your data structures. Key error. Description indicates an attempt to access a non-existent key in a dictionary. Causes. Using a key that is not present in the dictionary. Incorrectly specifying the key during dictionary access. Example: Python. My dict name John. Age 30. Print my dict address. No address key exists. This code will throw a key error because address is not a key in the dictionary. Resolution: ensure the key you are attempting to access exists in the dictionary. Not fitted error. Description indicates an attempt to use a model that has not been fitted to data. Causes. Trying to predict or transform data using a model that hasn't been trained. Attempting to access model attributes like coefficients or weights before fitting. Example: Python. Model linear regression. Print model, predictix model hasn't been fitted. This code will throw a not fitted error because model predict requires the model to be fitted first. Resolution. Ensure you fit the model to your training data before using it for prediction. Transformation, or accessing model attributes. 2. Beyond common exceptions. Convergence warning. Description indicates that the optimization algorithm used by a model may not have converged properly. Causes: poorly chosen hyperparameters, leading to slow convergence. Non-convex optimization problems where the algorithm might get stuck in a local minimum. Insufficient data for the chosen algorithm. Resolution. Re-evaluate your hyperparameter settings. Experiment with different optimization algorithms. Consider increasing the amount of training data. Data conversion warning. Description indicates potential data conversion issues, often related to missing values or data type inconsistencies. Causes: handling missing values in the data. Using data with mixed data types, e.g., numeric and categorical. Incorrectly converting data to the required format. Resolution. Address missing values appropriately, e.g., imputation. Ensure your data has consistent data types. Explicitly convert your data to the required format. User warning. Description indicates a potentially problematic situation, but not necessarily an error. Causes: using deprecated features. Performing operations that might lead to unexpected results. Resolution. Review the warning message and consider updating your code or using alternative methods. Deprecation warning. Description indicates that a feature or functionality is deprecated and may be removed in future versions. Causes: using outdated APIs or functionalities. Resolution. Upgrade your code to use newer, recommended functionalities. 3. Effective exception handling. Understanding the errors. Analyze the error messages carefully. They often provide valuable clues about the root cause of the problem. Review your code. Double-check your code for typos, data type mismatches, incorrect indices, and other common mistakes. Inspect your data. Verify that your data meets the requirements of the model or algorithm you are using. Consult documentation. Refer to the official scikit-learn documentation for details on pay exceptions and their expected behavior. Use try, except blocks. Handle exceptions gracefully using try, except blocks to catch and address specific errors without crashing your program. Example of exception handling. Python. Try, model, fitextrain, ytrain. Accept value error as a. Print error fitting the model a. Handle the error gracefully, e.g., log the error. Try alternative methods. Accept not fitted error as a. Print f model not fitted a. Handle the error gracefully, e.g., fit the model before proceeding. 4. Debugging techniques. Print statements. Use print statements to inspect the values of variables and track the execution flow of your code. Logging. Implement logging to record important events, exceptions, and data information for debugging purposes. Debuggers utilize Python debuggers like PDB to step through your code line by line, inspecting variables and call stack. Conclusion. Understanding and handling exceptions is a critical skill in working with scikit-learn. By grasping the common exceptions, their causes, and effective handling techniques, you can develop robust machine learning applications that are less prone to errors and disruptions. Always strive to write clean, well-documented code that handles potential exceptions gracefully, contributing to a smoother and more productive development process.